What happens in the brain when people make decisions? And which areas are really involved when we try to weigh actions, possibilities, consequences, and the possible emotional charge associated with possible outcomes? Now, a lot of work has been done recently on the neural foundations of decision making. So we're going to just focus on some core findings because I think they nicely demonstrate the constant battle that in some ways is always happening in our own heads. What they have found is that both the amygdala, which is a center for emotional processing, and the frontal cortex, which as we saw in the previous module is a center for executive processes and weighing decisions and weighing risks and so forth, both of those areas are heavily involved in decision making. And we'll see that those areas actually in some ways are often in direct conflict with one another. What we have discovered is the following. First of all, the amygdala seems to be able to respond in relative ways, exactly in the way that we'd think, based on the idea that reference points change over time. So if you remember, I described, going to a casino and then hoping to win $250, which seemed great when you entered, but then being up $5,000, and then all of a sudden $250 not seemingly being so great anymore. That's something that the amygdala seems to be coding for, changes in the reference point. So in the same ways they've found in studies that the amygdala becomes more activated for an outcome of getting $0 when the alternatives were possible losses, and that there's less activation when the alternatives were actually better. So in other words, if 0 is relatively a good outcome, the amygdala becomes more active. If 0 is relatively a bad outcome, then the amygdala becomes less active. In other words, it doesn't just respond to the absolute amount, it's relative to the context in which that value was provided. So this is similar to the idea of a utility calculation, where really we're looking at different numbers and different outcomes relative to the utility of the other possibilities of what could have happened. What else do we know about the amygdala and the frontal lobe? Well, what you can do is ask how emotional and rational areas, or in other words, the amygdala and the frontal lobe, guide decision making. They've done this a lot, but in one very simple experiment, you can do the following. You can give people a choice between either getting an immediate reward where they get $10, or you tell them that they can get a delayed reward, meaning they get $15 in 4 weeks from now. While they made these decisions, they were then put in an MRI scanner so that brain activation was recorded from the frontal lobe and the amygdala, and then they could see, depending on which of those choices somebody opted for, how did the brain activity in the two areas actually tend to change. And what they found was the following. Those who chose the early payoff showed relatively higher amygdala activation than frontal lobe activation. And those who chose the later payoff, getting $15 in 4 weeks, showed relatively lower amygdala activation and higher frontal lobe activation. So you see this nice interaction here where really what ends up being chosen is kind of reflected in the battle that's going on here between these more rational areas and these emotional areas. This is an example of temporal discounting, as they call it, which is the tendency to devalue outcomes that occur further ahead in the future. So in other words, $15 even tomorrow is not as good as $10 right now. And somehow people are very much driven sometimes by very instant rewards. And of course, sometimes this drives decision making. Dynamic inconsistencies are related to this phenomenon. So if I ask you, do you want $10 now or $15 in a week? You would probably take the $10 now. If I told you $10 in 30 days from now, or 15 in 42 days, or even 15 in 37 days for that matter, most of you guys would probably opt for the $15 instead, because this is all further along in the future anyways.